Hi everyone. Today we're going to work on probability, and it's basically why we pay what we pay for insurance. So it's kind of looking at it from a mathematical point of view, and we're going to take a look at some basic probabilities, some conditional probabilities, and we're going to be talking about independent events as well as putting together some Venn diagrams. So let's get into some terms, things like an actuary. An actuary is a statistician who provides information about risks and financial situations. They assist insurance companies in setting their rates. So basically they look at a lot of data and they compile it and then talk about putting together the probability of, let's say, someone in your age to getting in an accident. So they took a look at all the 17-year-olds in the United States, and they found the number of accidents those 17-year-olds were in, calculated some probability, and based on that, that is the likelihood that you'll be in an accident, and they base your insurance rates on that. And then they also divvy it up into categories like male, female, and age, and type of car, and whether you've had driver ed and on road training. So there's a lot of factors that come into play here. So remember, the probability of an event will occur is described by a real number between 0 and 1. And remember that they can be written as fractions, decimals, or percents. But we will never be negative, nor would we have a number bigger than 1. Now, an event is actually an outcome of an experiment, meaning we're going to take a look at a situation and what is the result. Okay. Now, a two-way table is basically like a spreadsheet. Okay, and it's used to depict the relationship between two pieces of data. Okay, so it could be age and type of car. It could be male, female. It could be cars and accidents. So you're looking at two different things and kind of organizing it into basically a big table. Conditional probability is the event that will occur given that another event has already happened. So basically, you can think of it as, what is the probability that I'm going to get in an accident given that I drive a pickup truck? Or what's the probability of getting in an accident and I'm female given the fact that I drive a Honda Civic? So those are the types of questions. Now, independent events are two events in which the probability of one does not affect or influence the outcome of another. So if you think of maybe if I roll a die and pick a coin or toss a coin, the outcome of rolling a die doesn't affect the outcome of tossing a coin. That's what we mean by independent. Now, events that are dependent are called associated events. Those are events that influence each other. An event diagram is basically a picture display that represents universal sets and events like intersecting events, things along that line. So there's a rectangle and there's some intersecting circles. And we're going to look at those a little bit more closely. All right, so let's take a look at some probability problems involving cars and stuff. So we're going to do a simple one first and work our way up to things that are a little tougher. So we have a pail that contains 7 red, 6 green, 3 orange, and 4 black marbles. One marble is drawn at random. What is the probability that the marble is a red? Now there's going to be some notation that we're going to need to come familiar with. So I want to do P is going to be probability, and our R is going to stand for red. So this is probability. And the R is our event, which is a red marble. Okay, so if you remember from way back, when you learn probability, like in middle school or elementary school, it's the number of times something happens over the total. And that's exactly what we're going to do. So we're going to take a look at how many red marbles we have, which is 7, over the total number of marbles that we have. So 7 and 6 is 13. I apologize. And then 3 more is 16, and 4 is 20. So 7 out of 20. So remember, these are the red marbles, because that's what we're interested in, and this is the total. Okay, now you can divide that and get the percentage or the decimal, which would be 0.35, or you can write it as 35%. Okay. All right, so let's try another one. We have a driver's ed class in Monroe High School, has 23 girls and 20 boys in it. If one person is selected to represent the school in a driver safety exposition, what is the probability that person will be selected as a girl? So we want a probability that we're going to have a girl to represent the school. Well, we need the number of girls, which is 23, over the total number of students, which is 43. Now, again, you can leave it just like that, or you can divide it and write it as a decimal. We'll go 2 decimal places and write it as a percent. Okay. All right, so let's take a look at I apologize, I don't know, something's up with my notability. What is called a two-way table. So this is a two-way table. And across the top, you have type of vehicles. And down the side, you have shifts. Shift meaning morning, day, night, and then you have a total row and a total column. So we have a factory here planning to rearrange the parking spaces in a parking lot to better serve their employees. The employees work in 3 different shifts and drive 5 different types of vehicles as displayed in our table. An employee is selected at random. What is the probability that an employee drives an SUV? So we're going to look at all of our SUVs. Here they are. And you notice there is a total column, and it tells us that there are 91 SUVs. So they got that by doing 42, 30, and 19 and adding them up. Now remember, just like we did with the girls and boy, we want to know probability of driving an SUV. So we need a total number of SUVs, which is 91, over the total number of vehicles, which is 246. And keep in mind that's right over here into the total column. Okay. All right, so when we divide that, we're going to get 937.37 or 37%. Again, that's rounded. Okay. All right, so we're going to be using this table for a few problems. So let's take a look at the next one. So we still have an employee that's selected at random. Find the employee is on the night shift. Okay, so night shift is right here. There it is. And here's our total of night shift, which is 59. So we want the probability of a night shift. Let's do NS there. So we have 59 employees out of our total of 246 employees. So we get a total of, let's make it 0.24 when I divide that, and that'll be about 24%. Okay, why would that be important? Because if we have most of the morning shift versus night shift, we might want to rearrange the parking spaces. We might also want to consideration safety, so they might want to put the night shift closer. All right, so again, we're still using this table. And the factory is thinking of closing part of the parking lot at night since there are fewer night shift workers. What is the probability that an employee drives a motorcycle given that they work night shift? All right, this is a conditional probability because we know something is going to happen. We know that they work the night shift. So what happens here is that when you know that's going to happen, you're only going to look at that particular situation. So night shift is this row. Okay, so I'm only looking at those 59 employees. So what we want to know is out of those 59 employees, how many drive a motorcycle? Now I'm going to give you some notation. Please don't stress about the notation. So a probability that we drive a motorcycle given night shift. Okay, this vertical line in probability means given. So the given part always comes second. What we're interested in always comes first. And one of the ways, the little shortcut to help you with this is that what's given is always going to be the denominator of your fraction. So we have 59, okay, night shift people. And out of those 59, let's come here, out of those 59, 5 of which ride a motorcycle. So that's going to be our numerator. Okay, so it's motorcycles that work night shift. Okay, so 5 over 59, we're going to get like 0.08. We're going to round that to 8%. Okay, so let's try that again. So find the probability that a randomly select employee works night shift given that they drive an SUV. All right, so here's my given. Drive an SUV, which means that I'm only interested in SUVs. So let's write our night shift given SUV. Okay, so I'm only going to look at the row or the column that's SUV. So let's find that. So let's find SUV. Here it is. So I'm only interested in them, which means my denominator is going to be 91. And I'm interested in the people who are working night shift. Here they are. So SUV night shift is 19. So it'll be 19 out of 91. Okay. When we divide that, we're going to get, let's make it 2 decimal places, 0.21 or 21%. Okay, so let's try some more of this. Justin's doing a statistical analysis to check if the sports cars in his town are involved in more accidents than other types of cars. Okay? He polls 315 randomly selected parents of high school students and gets the result. And again, we have a table here with information. We have our total up and down. We have our total horizontally. We had sports cars, sedan, and SUVs, had an accident, and never had an accident. All right, so let's take a look at the questions. Does the table support Justin's theory that a sports car gets in the accident more accidents? Well, let's find out. Okay, to me, that looks like, let's just look at sports cars. Here they are. Okay, and to me that means get into more accidents. So does it have an accident? So let's write this as the probability accident given sports car. Okay, so make that 50 out of 105. That's 0.48 or 48%. Now, how am I going to compare that to saying, because that's given that they're a sports car, accidents. Well, we can compare that to just the number of accidents. Okay, so we want to compare that to, let's find the probability of just accidents. Okay, so accidents are going to be 150 out of 315. Now, I don't know how I'm going to compare that, but let's change it to a decimal. So 0.48 or 48%. Okay, they're the same. So that tells us that since they're the same, the two events are not related to each other. They are independent. Okay? So one of the things that we're going to have to think about is when we talk about independent events, that the outcome of one does not influence or affect the outcome of the other, that a probability of an event is the same, well, let's use A, just for argument, as the given. Okay? So when that happens, that means these events are independent. Okay? Now, sometimes we can just look at it and say, yeah, they're independent events. Sometimes we have to do the math. Okay? All right, so let's look at Javia here is judging a classic car show, and she's preparing a report on cars in the show. There were 135 cars. 70 of the cars had manual transmission, 43 had air conditioning, and 13 had both manual and air conditioning, and 35 had none of the above. The car will be selected at random appears to be on the cover of the report. What's the probability of a car with air conditioning but not manual transmission? That's a lot. Like, how are we going to figure this out? So we're going to use something called a Venn diagram. So we're going to draw ourselves a picture. So the first thing I'm going to do is draw a rectangle. Okay, so there's our rectangle. And in our rectangle, this is going to be all cars. Okay, so let's label this with a color, and this is going to be all cars. All right, we'll just call that all. Now, I'll give each buddy a color. We have cars with manual transmission, 70. So I'm going to draw a circle with manual transmission. Okay, and this is going to be our manual. Okay, then I'm going to draw another circle that has air conditioning. And I'm going to intersect both of those because some of them have both. In the center here is both manual and air conditioning. All right, so let's put some numbers in here. Okay, so it says 70 had manual. Okay, so 70 was manual. Okay, and 43 had air conditioning. Let's just call it AC. 13 had both. Okay, now if I put the 70 into that circle that I have labeled manually, that's including the 13. So I basically want to do is just include only the manual. So I'm going to basically like kind of shade this section, see how this, I'm going to look like this. And I'm only going to write how many manual transmissions there were without air conditioning. So that's going to be 70 minus 13. So let's label this only manual. And that's going to be 70 minus 13, or 57. So there are 57 cars in this circle. Okay, now we know 13 of them had both. Okay, so that's 13. And now let's figure out only AC. Okay, so that's 43 minus 13, that gives me 30. Okay, so that's going to go in the AC one. So that's this guy over here, just AC. Okay, so that's 30. Okay, so 57, 13, and 30. Okay, 13 and 57 give me the 70 for the manual. 13 and 30 give me the 53 for AC, and the 13 in the middle there, that's the one that has both. Now, how many cars are left in the whole all box? So there was a total of 135. All right, so let's do, okay, so let's say cars that are left. So I'm going to do 135 minus the 13, that's both, minus the 30 for AC only, and minus the 57 that was only manual. Okay, so that's 35. Okay, so that's what's going in the all. Okay, so that's 35. Okay, so hopefully that made sense so far. Now we're not ready, we didn't even find the probability yet. So let's make some room here. Okay, so we want to find the probability that the car will have air conditioning but not manual. All right, so air conditioning, I have that as blue. So probability of air conditioning. All right, so we had 30 with just air conditioning out of, I don't know what is going on here. Okay, out of the 135 total cars. So that's going to give me about 0.22, so 22%. Okay, that car would be on the cover of the report. Okay, so let's look at another Venn diagram because we haven't really worked with those before. So, following Venn diagram describes cars on the lot of Marcelli's used car showroom. The letter B is used for if the car exterior is black. T is used if the interior color is tan. All right, so let's look at this for a minute. Okay, so we have black. All right, so these guys are just black. Okay. And T is for tan. So these guys are just tan. And in the center, what color do we want to use there? Okay, let's use orange. Our black tan. Total number of cars. Okay. We're going to have to add these together. Okay, so sorry about that. That 112 is everybody else. So we're going to have to find the total. So we're going to have to do 17 plus 8 plus 39 plus 112. Because 112 is how much is like not black, not tan, not both. So we should get 176. Okay? All right, so let's take a look at our questions here. What's the probability that a randomly selected is not black? Okay, so to me, that's 39 and 112. So 1 can't add 151. So probability of not black would be 151 over 176. Okay, now you can write that as a decimal if you choose to do so. So about 86 or 86%, depending on what the problem asks for. All right, so again, we're going to use this Venn diagram. How many cars have a black exterior or a tan interior, but not both? All right, so this is just black or tan. So black and plus tan. Let's do it that way. So there's 17 and 39. So that's 56. So the probability of black plus tan is going to be 56 out of 176. Okay, so I get about 32. So 0.32 or 32%. Okay. All right, guys, let me know if you have any questions. Remember, if we stay in, we're going to keep each other safe, and I'll talk to you again real soon.